Hi dear all, we are looking after a very long break, is it right? No problem about this one. I just want to tell you about some more things. That means another topic has to be done, is it right? I hope still. Surely you would have got my fluency, is it right, my asset? No problem, while looking at the back videos you can get that one very clearly. Now look at this one. Now I just gone about orthogonal matrix, okay, that person of orthogonal. Look at over here, I just write here for you, okay? Orthogonal matrix, okay? Orthogonal matrix means that if you multiply two matrices, the resultant will be 0, okay? That is a very important thing. That means multiplication of a matrix will result in the form of a 0 matrix. That 0 matrix means what all the elements will be 0 of a matrix, okay? So let me take some two or three matrices, okay, so that I could find each and every multiplication of all the matrices will be giving the 0. For that I'm getting some other form of a matrix for each and every matrix, okay? Just like this here. First one I take x1 is a matrix, okay? Second one I take x2 is also a matrix, okay? And third one I take x3 is a matrix, okay? Let's look at over here. But this matrix could be any more entries because I'm going to write a set matrix. Here also one set, here also one set. But there could be no problem because any type of element will be there. But if you multiply two matrices and the result should be of a 0 matrix, okay, that's very, very important here, okay? So for this I want to get some assumption of all the elements of a matrix so that the resultant value will be 0, okay? We can't take all the elements, we can't take any elements because this is not possible because we want to just get the elements so that the multiplication will be giving the sum of 0, okay? My flow will be very speed, but no problem. While looking at the back of video repeatedly, you get more knowledge, okay? Also you'll be getting more and more good English and a good fluency so that you may go for good communication to get the more jobs in a very great multinational companies, okay? Thank you. Just wait. So I just got it. 1, 2, 2. Purposely I'm taking this element, okay? So orthogonal means, because if I take this means, look at it over here, something should be changed with respect to its sign, okay? Now example, because if I just write means you could understand very clearly. 1 to 2 means the second matrix I have to take in the form of 2 1 minus 2. Look at it over here. This one has come over here. Is it right? The 2 has been shifted over there, and automatically remaining part is this one. Is it right? Because these two got swapping, remaining part will be getting the minus. Okay, this is a clue because I don't say that this is the matrix form. This should be the matrix form when I just write x1. It's not about the possible. Okay, you can write any more matrix, but only for getting the answer result of 0, I'm making the matrix in the form of this sort of way. Okay, so I want to get an x3 also. Is it right? So for the x3, what I'm going to do means, here I got 2 minus 1. That's no problem about this one. Here only the entries are changing, minus are staying, okay? Because I got these three forms so that if you multiply any of the two matrices, no problem with this one, the resultant value will be the giving a form of a 0 matrix, okay? Let me check about this one by multiplying each and every matrix, okay? Now I do x1 dot x2, x1 dot x2. Previous class I said about how it is going to multiply, because x1 x2 means what? x1 x2 transpose is equal to x1 transpose x2, okay? One of these two matrices will be getting the transformation, okay? So now let me do one more thing here. I take this one, okay? Both we can take, no problem, both will the same value, but anyway let me take this one, first one. So what I have, so x1 means what? 1 2 2. And x2 transpose means what? All the first column will be changing to the complete row. Okay, so 2 1 minus 2, just with the multiplying first row. I'm sorry, that means what? First row, first column. So what's this one? First row, which is equal to first row, first column. 1 into 2, do the bracket, okay, it's working for you. Second row, second column, because only one entry in the first column, only one entry in the first row, so that the multiplication stop up together, okay? So now 2 into 1, second row, first column, then third row, first column. So third row, third column, second row, second column, third row, third column. So plus 2 into minus 2. Is it right? So 2 into minus 2. Anyway, I can write anyway, no problem. So 1 into is what? 2 plus 2, and then minus 4 is equal to 0. Now we got it, is it right? So this is for what? x1 into x2. Now let me go for x2 dot x3. Okay, so what I do, I just wrap up these things. No problem about this one. Now I gotta go for multiplication of another two. There's remaining two. So what I do means I just going for x2 dot x3, or just equal to. So previously, before that, I have to write the representation of matrices, right? So x2 dot x3 transpose, otherwise x2 transpose x3. Okay, any type of form we can take. For last time we taken the first form, is it right? This time I take the second form. Okay, no problem. So automatically I just wrap this one. So let me take this one. So what is x2 transpose? This whole column will be changing to one row. This row, this column will be changing to a row. So that means 2, 1, minus 2. x3, right as it is. No problem with this one. 2, 2, minus 1. Which will be equal to first row, first column, is it right? All the entries of first row should be multiplied with the first column. That was once again I repeat for you. All the first row of the first matrix should be multiplied with all the first column of second matrix with the corresponding elements. That means position 1, position 1, position 2, position 2. This is 1 cross 1 matrix. Okay, is it right? Likewise, you can do for 2 cross 2, 3 cross 3, anything, no problem. So 2 into 2, 2 into 2, 1 into 2, plus 1 into 2, and then plus, just do the plus, okay? Minus 2 into minus 1, is it right? So minus 2 into minus 1. So now I think I hope I have made a mistake, is it right? So minus 2 and minus 1, I think will now be coming 2 into 4 and 1 into 2, so 4 plus 2, 6. And then 6 minus 2 is it's not about this, just make a small weight here. Just I want to just make a thing. So I just I hope please wait, I just make a small assumption here. So that means I don't know about this one, 2, 1, minus 2, more minus 2, 1. I'm sorry, listen here. First of all, I set up this one because I just made a small mistake here. Because I told about minus is coming here, is it right? Now if I change this means automatically this one should go this side. So please just make a small change, is it right? Because I didn't just forgot to say sorry for everything, okay? So automatically this is minus 2 and this will be plus. So 1 into minus 2, this will be minus 2. So I just wrap one more time and then just write for you one more again, okay, no problem. So here 2 into 2 plus 1 into minus 2 plus, so 2, 1, minus 2, okay, this one. So minus 2 into 1. So it will be 4 minus 2 minus 2. Automatically 0. So let me just apologize for one small thing because previously the first time I didn't say about this one. Anyway, no problem, we just got it reset right. So automatically x2 dot x3 is 0. So first we got x1 into x2 is equal to 0, and second one x2 into x3 is equal to 0. And now we want to check about for next one x3 into x1 because it goes in the form of circular way. x1, x2, x3 means x1, x2, x2, x3, then x3, x1. Okay, so first two conditions we completed and we got about the last condition. Okay, so one more time, I just write for the x3 into x1. So x3 into x1 is equal to x3 transpose x1. Okay, take x3 transpose just one column into row. So 2 minus 2 1 into what's x1 1 to 3. So what's around 2 2. That's equal to, so first row into first column. 2 into 1 plus of minus 2 into 2 plus 1 into 2. So 2 minus 4 plus 2 is equal to 0. 2 minus 4 minus 2 plus 2 is equal to 0. So automatically I just write the third condition is about, so x3 dot x1 is also equal to 0. So this is called orthogonality. That means for the three matrices, when I just multiply each and every matrix with itself, that means with a neighbor. I'm sorry, this is not when this is a neighbor. So the product should have to be get the value of 0 as a result. This is about the orthogonal property. So let's